Hello and welcome to Calculus tutorial. We are going to take a look at our fourth and final limit technique. It's this weirdly named one down here, and the way you say that is L'Hôpital. It's L'Hôpital's rule. Yes, it's spelled El Hospital. But it's French, and so you call it L'Hôpital's rule. And it's a very powerful and easy rule that has been added to the calculus curriculum fairly recently, actually. And there's two scenarios where you can use it, if you're doing a real valued limit or a limit at infinity. So it is very useful because it can be used for both. So let's take a look at what L'Hôpital's rule actually is. First, it is actually spelled in two different ways. Either one is fine. If you want El Hospital, that is correct. Or if you want to take that S out, L'Hôpital can also be spelled that way. In the French language, it's the same. So, in a nutshell, if you have a limit that you can't do, one option to you is to take the derivative of the top and the derivative of the bottom and then try again. And if that doesn't work, you're actually allowed to do it again and again and again. Hopefully you remember taking the derivative simplifies things a lot. And so this can actually be a very powerful tool. The caveat is you're only allowed to use it if you have what's called an indeterminate form. So if you try to do your limit and you get 0 over 0, we don't know what that is. It's an indeterminate form. You are allowed to use this rule. Or infinity over infinity. Those are sort of the two popular ones. Some other indeterminate forms where you can also modify this to work are 1 to infinity, 0 to the 0, or infinity minus infinity. But these two here are the most popular ones that you'll see most often. So once you have an indeterminate form, you can try to take the derivatives and try your limit again. So let's take a look at how this works with a simple real valued limit. So here we have a limit as x approaches 1. And so what we do first is we try to plug in 1 to see what happens. So it's not really equal to, so I'm just going to put an arrow. If we try to plug in 1, we get 1 minus 1 on the top. On the bottom we get 1 minus 1, which is 0 over 0, which is an indeterminate form. And so this says that we are allowed to use L'Hôpital's rule. And so what we're going to do is simply take the derivative of the top and the derivative of the bottom. So the derivative of top is 5x to the fourth. And the derivative of the bottom is 3x squared. And then we try again. Can we plug in 1 now? And we can. We will no longer get 0. 1 to the fourth is 1, times 5 is 5, and on the bottom we also get 3. So we no longer have an indeterminate form, we know what the limit is, there are no problems. 5/3. Fairly easy technique, but powerful. Just make sure you do have to show that you get an indeterminate form before you use L'Hôpital's rule. You can't just start taking the derivative of everything. That is no bueno. Alright, so that's how that can work with a real valued limit as x approaches a number. But this technique can also be used for limits at infinity. I don't think we've seen one of these before. You did them in trig though as n behavior. What is the limit as x approaches infinity of this equation? So not as x approaches a number, but as x approaches infinity. Well, first you plug in infinity, which is just an infinitely large number. So if I take a huge number, square it, multiply by 2, and subtract 6, that is still going to be an infinitely large number. On the bottom, if you take an infinitely large number and multiply by itself 4 times, subtract 8 times infinity and add 9, what will that be? Well, yes, subtracting 8 times infinity is a lot. But you're taking infinity and multiplying by itself 4 times, that's much bigger. So that overpowers everything and you again get an infinitely large number. Which, what is infinity over infinity? We don't know. That is an indeterminate form. So now that we have stated that, we are allowed to use L'Hopital's rule, which says take the derivative of the top and the bottom. So the top will be 4x, and the bottom will be 4x cubed minus 8. And if we plug in infinity now, 4 times infinity is infinity, and 4 times infinity cubed minus 8 is also infinity. We have another indeterminate form. Which actually is kind of nice, which means we can just do this again. So take the derivative one more time. So we have 4 on top, and on the bottom we have 12x squared, which brings us to 4 over infinity. Now that is not an indeterminate form. It wasn't one of the ones we listed because we know what this is. If you take the number 4 and divide by an infinitely large number, you are going towards 0. As you divide by a bigger and bigger number, you get smaller and smaller, and if you divide by an infinitely large number, you are going towards 0. So it's a very fairly easy technique algebraically to do, and so that's why it's important for us to know. Just take the derivatives, but make sure you only start taking derivatives when you have determined there is an indeterminate form. So all of our limit techniques, if we go back to all of them here, we have L'Hopital's rule, which is very powerful and actually quite easy to do. But we also have our other 4 techniques as well, the dividing out, multiplying by the conjugate, and the squeeze theorem. So that rounds out our 4 different techniques for taking limits.